All right, so let's go right ahead and do a quick example of boiling point or freezing point colligative property. Antifreeze, as I mentioned, protects the cars from freezing. It also protects it from overheating because, again, it elevates the boiling point, depresses the freezing point. Calculate the, so here I am again, calculate the freezing point depression and the freezing point of a solution containing 100 grams of ethylene glycol, which is Ch16Sec6 in, I'm going to put in 0.500 kilograms of water. The KF for water, this is the KF for water, is 1.86 degrees Celsius per molal. All right? Now you can pretty much, obviously we're solving for the change in temperature, so we know we're going to be needing this formula. Okay, we're going to need that KF times molality. So let's go ahead and start solving for it. The change in temperature of the freezing point is KF, which is 1.86 degrees Celsius per molal, times the molality. Where's my molality over here? I'm not given it yet, okay? But I know that my molality is moles per kilogram. So this is a situation where you need to solve basically for two formulas. Moles per kilogram. So molality is moles of, again, I should really write it out here, solute per kilogram of solvent. Which one of these, the 100 grams or the 500 grams, right, 0.500 kilograms, is the solute, and which one's the solvent? Well, notice the in. This ethylene glycol is the solute. This water is the solvent. So I need to take these grams of ethylene glycol and solve for moles. X line, grams, moles. I add up ethylene glycol, I think it's 62. All right. And if I divide that, I get 1.6 moles. And I'm going to divide that by the kilograms of solvent, 0.500 kilograms. Divide that is going to give me my molality, and that is 3.2 molal. I now can plug it into my formula over here on the right, 3.2 molal. Multiply that by my 1.86, and I get 5.9 degrees Celsius is my change in temperature of the freezing point. Now I also want the freezing point and the new freezing point, which again, water, because I'm talking about water freezes at 0. So if the change is in the negative direction, right, it always depresses, then my new freezing point would be negative 5.9 degrees Celsius. So that's the second thing that you would need to solve for in this, this question. All right?